Hello, this is my video for the first homework assignment for LabVIEW for ENEE 4800. I'm Zachary Alt. And so just going through the program real quick right here on the front panel, I've got inputs in for the temperature, um, for NA, ND, VR, which is in EV instead of V, which is important, and I'll touch on in a second. And then this is like initial junction capacitance needed. Here in the block diagram, it's a pretty simple program. So everything is encased inside of a while loop that is wired up to a stop control button. The stop control button you can see right here on the left side at the very bottom. That's how you can end the end loop without ending the program with the like top admin control. And the first step in this was defining all of my constants. And so based on the problem statement, it you see the equation right here. So this is for the built-in potential for the voltage. It needs to be solved first. And then that what is necessary is the Boltzmann constant, temperature, and the electron value. And so K and E are both constant constants. They don't change. And so they're not going to be an input. Temperature, NA, ND, and then and NI is also going to be one that doesn't change. And so it's just given a constant, but temperature, NA, and ND are each input variables. So whatever conditions that we want to model, and they can be changed right here in the front panel by adjusting these values. You can type it in into the white box, or you can use these up and down arrows. The up and down arrows aren't going to be as useful on the big numbers like 1.5 e to the positive 16 because just like the scale, it only matters on the numbers on the far side defining it. But temperature, it adjusts it a lot more. You can see the difference. So each one of those is the input, and then they get fed into here. These are just equation blocks that I used, and I typed out the equation that was they were trying to model. So this gives our built-in potential or built-in voltage, and that gets fed into an indicator because I wanted it to be shown at any given time when someone's solving for it. And that's what this block right here on the front panel is showing. And that's then, while it's the output for that equation, it becomes the input for the next equation block. So the built-in voltage is going to get put in right here, and then this is for the junction capacitance. So this is just a different equation plugged into another equation block. And then I had two more inputs. This is VR and this is CJ naught. And VR is important to note because it's given, or the value is in EV, not V. And I looked it up, and the reason I had problems with my like calculations was because I kept putting them in volts when this number is like 10, 1 EV is like not exactly, but it's to a factor of 10 to the negative 19 difference. And so that was a big problem. But um, once putting in the number and converting it, then you get more reasonable changes in the junction capacitance. And so that gets plugged in, and that just becomes the output, which is another indicator block right here. And it just like right now the program is running. You can tell by the black arrow with the lines coming past it, and if you hover over it, it says running. But I can change stuff like the temperature and adjust both values because the VBI is necessary for as the input for this. So when this changes, the CJ changes the junction capacitance. And if I want to end the program, all I have to do is hit stop. And that is all.